may have difficulties to understand this direct integration. Okay, this direct integration is quite straightforward, I believe, but except this part, I want you all to pay some attention here, whereby it cannot be C, a constant. It must be a constant function, okay, which could be the constant function depends on the variable that you made it as a constant for the partial differentiation. Okay, with that, now we move into the topic, the actual, things for you to work. Okay, now again, don't, sometimes we used to give direct integration in the partial differential equation. Students sometimes they may overlook and they may think, oh, this must be a partial differential equation. They started doing with another method. No, you must understand, direct method also one of the solution. Okay, one of the solution for partial differential equation, but that must be a single differentiation. I forgot to tell you this. Okay, you cannot do more than one. It should be a very one simple del f x y z, whatever level, we don't care. Okay, but remember, it should be based on a one x or y or whatever. It can be one of the things that you are referring to. It can be 3, means it could be 3, but 2 here in our case is a 2 enough, because we are not going to learn more than that. Okay, this x and it could be double, okay, and it's a g xt. Only double integration can solve this kind of combination, 2f(x,y) dx del y equals to gxt. I forgot to tell you just now. Okay, another combination it may solve. Another one more this is not a y, it's a t, right? If it is a t, it should be t, it cannot be y. Okay, this should be t. Okay, this one xt. Okay, another combination that you can expect is f x t, and this can be del t power 2. Okay, g x t. Okay, only 3. These are the only 3 that you can solve with the direct integration. Other method, okay, if you wanted to solve other than this, you need to use some other method. Only you can see, okay, for the x, okay, and for the combination of the x and t, but single, okay, single equation, single order, order equation. You can see there is a single. It's not a combination of many orders, you see. Therefore, you can see it's a single order. Only these 3 is possible to use direct integration to solve. Okay, I hope that you can understand this process, this method to solve. Okay, with that, let me move into today's topic. Okay, I have always, because my battery, that is one of the challenging one to me, because separation of variables. Okay, separation of variables. Okay, how to solve the separation of the variables? This is one of the powerful topic which it will take, I think, a longer time. I don't know whether I can finish this within 2 hours, or in I got around 1 hour 26 minutes. Yeah, okay, apply. Okay, this, in order to use separation of variables, you should able to apply to only linear homogeneous method. Okay, linear homogeneous. These 2 terms is very important. Another one more, it must comply. In order to solve using a separation of variables, you must comply these two with homogeneous boundary conditions. Okay, it should comply this homogeneous boundary condition. No boundary condition, of course you cannot solve separation of variables, and apply to only linear homogeneous. I already explained to you linear. Okay, homogeneous just now I did explain to you. Linear, as you all know, they cannot be a what is linear. Okay, linear, instead I explain into detail what is linear. Let me put it to you, this is linear. Okay, imagine other than this is not linear. Okay, this is linear, this is a linear equation. Okay, this combination, whatever the combination that you may get it from here, is a linear. But what is not linear? If somebody asks me, okay sir, what is not linear? Okay, can you explain to me what is linear in this case? The linear is non-linear equation. Where is that? The linear, okay, non-linear equation. Okay, the non-linear equation is like, for example, you see x, there is an x. Okay, the product term of the same equation, for example ux. Okay, what is the another one? It could be u. This is the product term of dependent variable. There are two dependent variable, the product of two dependent variable. Or okay, what else cannot be this thing? Degree must be always 1. Okay, there are 3 conditions to follow, as you all know what I mean by linear. Okay, linear, first condition, the degree. Okay, the degree must be 1. Okay, as you all know, must be 1. Okay, that means it cannot be like u xx power 2, cannot. Okay, because it's a degree should be 1. Okay, this is degree, this is order. I'm saying order is different from the order, means is how many times you are differentiating. Okay, this is a power 2, that means your times with the ux is different. Okay, therefore this means is ux times with the ux. Okay, two differentiation is a two different thing. Okay, therefore degree is referring to this. Okay, number 2, what is say? No product, already no product of dependent variable. Product term, no product term, term of dependent variables. Or dv. Okay, I'll say dv. Okay, no product term of independent variables. No product means it's a times. You cannot times, like for example u. Okay, u is this, which one is a dependent variable, independent variable? I hope that you all know this lah. Okay, is I cannot repeat many things here. Okay, dependent variables, as you can see, for example, which one is dependent, which one. Okay, for example here we are using a dt. I don't want to introduce y here, sorry, many times. This is a dependent variable. This both x and t are independent variable. Okay, remember, no product term of dependent variable. That means if I start using u to the u, cannot. Okay, it's a product, cannot. This is not a linear. Okay, this is not a linear. The third one, you cannot use a transcendental function. I cannot repeat the same thing. What I mean by transcendental function? No transcendental function. What I mean by transcendental function here? Function here is something like this. Okay, no transcendental function on what? On dependent variables. Okay, no dependent variables. Okay, that means you cannot use, like for example ux, this is a transcendental function. Okay, when you start use a transcendental function on the dependent variable, it's not anymore what we call as a linear. Okay, this is the definition of the linear. Homogeneous, I already explained to you, there cannot be a gx. Okay, this. Okay, see, a lot of things to explain for the particular one single, compliance. Okay, this is very important, understanding why. Maybe you may say, why, sir, why are you spending more time here? Okay, this is very important. Okay, very important. But later I'll tell you why. X, I'll give you some simple these things, whether it's a separable or not separable. Which one can be a separable? Okay, you already learned separation method. Here, X and Y. Okay, this is a separable. How do I know? This I can write as X, Y. I can separate this into two different functions. Okay, I can separate this to two separate functions. Example, okay, example is X. Okay, is X, Y, Y. I can represent it as this. Okay, therefore I can separate. This is, we call it as separable. Separable. Okay, this is very important. Okay, number one, maybe I'll give you more examples. Okay, is it a separable? Is it separable? Can I separate this? Cannot. Okay, this we call it not separable. This is not separable. Okay, number three, why this knowledge is important? You will know later why. Okay, X, Y, is it a separable? Yes, it's a separable. Okay, we can separate this. Are you agree with me? You can separate this, right? Can. Separable. Okay, what about this? Number F R to the theta. Is it separable? R plus Q? Yes or not? Yes, right? Separable. What about this? F R theta, E R theta. Is it a separable? No, this is not a separable. It's not a separable. Okay? Okay, with this up to here, we now know what we mean by separation. Okay, separation means we should be able to separate that to separate functions like this. Okay, therefore we call it is a separable functions. Okay, with that I would like to ask, every year I used to give rewards to the students, those are answering this question. Okay, this time I won't be able to give it because we are doing this pre-recording. Anyway, you can give a try. Maybe I may give you maybe few seconds to think and answer this question. Okay, don't just simply take it this. Okay, in which circumstance, if fx can be gt? I'm not going to say simple question. Okay, you just answer this. When fx can be equal to the gt, in which circumstances? Is there any circumstances that can equate these two both possible? Do you think it's possible to equate this? In only one condition, both can be equated into one solution. Okay, you see, this is a separate, it's a different. I don't know maybe whether you get it this question clearly or not. The first thing, the x is a different independent variable. Okay, and this functions representing different independent variable, and in which circumstances both can be equal. Okay, this is actually we call it very important $1 million questions. But I won't be able to give you that much of money lah. Okay, but I'm just saying it's very important for you to, if you can answer, beautiful. Okay, it's a very beautiful. Yes, some of you started think. Okay, you already managed to see. Yes, sir, I got it. In one circumstance, both different functions, different function can be equated. Anyone? Okay, seems some of you got it. Okay, very good. Those managed to answer my question is very good. Okay, I'll give you the answer. Now you just verify, because I'm not going to save the paper, but here I just, for this case, if anybody managed to answer, you are very good. Okay, GT. Okay, then the answer must be fx gt equals to constant. It must be constant. If in any circumstances, if fx equals to gt, the answer must be constant. If not, you won't be able to solve it. This is very important. Okay, this is very important. By now you should be able to answer lah, because you already gone through your lecture. Okay, your lecture. I hope that you will able to understand this. This is very important equation. Okay, now, okay, with this, let me move with some revision, quick revision with you. Okay, there are, okay, still we got some time. Okay, revision. Okay, I wanted to do one quick revision. Okay, you may ask, sir, why are you doing many revisions? Okay, but remember, this is a pre-recorded. I don't have any other choice. I won't be able to see your face anyway. This is I'm trying my best to accommodate all levels, all the levels. Therefore, I'm a bit careful and slow. Okay, in order to make sure that every one of you understand what I'm teaching. Okay. Okay, now you can see y equals to 0. What is the solution of this? Can I solve any solution for this? Yes. Okay, the solution of this you can easily solve, and you get a y equals to CEEX. How am I solve that? Okay, how am I solve that? Okay, it's a y dy to the y. Okay, where I get a what? Here. Can you see that? A. Okay, and this become dx. Can I differentiate? Yes. If I start differentiate here, I get a ln y. Where here I get a ax. Okay, I bring it up here, I get a e. And okay, don't forget to incorporate the c. C don't put it here. Okay, c don't put it here, because ln e gone up, then basically it's a ln ax, and it can be a plus c, but the plus c I can put it that as a. Okay, this is the solution for that. Okay, what about the solution for this? Okay, again you can give a try for the another one. Okay, y axy equals to 0. Can anybody manage to solve? Okay, try and see. Okay, similar ax here. Okay, but here ax, okay, once you get it here, this is the solution. Wow. Okay, ax2 to the 2. Okay, I believe almost all of you managed to do that. Okay, come back to this. This is a very important one. Okay, I put a star, double star, maybe I can put a triple star. Okay, this knowledge is enormous. Okay, enormous means you're going to use throughout for the PDE. Okay, let me show you. Double prime alpha, sorry, not alpha, lambda y. Okay, lambda y. What is the best solution that you already know to you? You already know this is a EMX. Okay, this is the solution. Then can I use this solution here? The solution is m2 lambda equals to 0. Okay, the lambda, then can I use okay, when you change it that to m, you will get a plus minus square root of lambda. Okay, with this something, can I quickly conclude and just place the things? Cannot, because lambda here is a constant. Okay, I've chosen something called constant. If constant, I need to define this lambda properly. Okay, I'm going to define this in a 3-way. Okay, for the lambda. Okay, you see first, if lambda is equals to p squared, okay, which is greater than 0, I place it here, I get a m positive, right? Therefore the m become positive p squared, then I get a plus minus p. Therefore my solution will be a, okay, e px, b e negative px. Okay, this is so far good. Else if okay, I hope that you can follow me. Sometime I never follow the camera. Sometime I just, okay, because I worried whether you can see what I'm writing here. Okay, if lambda equals to 0, what I'll get it? Okay, if lambda equals to 0, I should get as a y equals to what I supposed to place here. Okay, if lambda equals to 0, what suppose am I need to write here? Okay, is the lambda equals to 0, the x, what suppose the answer will be? Is a 0. Okay, is a constant, right? Constant. Therefore, can I write this as a constant here? Cannot. Why? Why cannot? Can I place it this as a C1 here? Cannot. Because this is a, we are not complying the rules of superposition of what? Second order principle, superposition theorem. Superposition theorem saying there must be a two answer. Okay, combination of the two answer for second order equation, right? Therefore you need to provide this as a x and b. Okay, remember this is a one constant, you cannot apply the constant because there must be a two solution, combination of two solutions. I did explain this in detail, but I cannot go back in this circumstance anyway. Okay, please understand, this is the answer for you. But please, if you have forgot this rules, please revise back your first semester. Okay, now else, what is the possible solution that you may have here? Is a lambda p2, okay, which is less than 0, okay, which will give you plus minus ip. Okay, what is the solution? In order to solve this solution, you should go back to the Euler formula. I really one of the most powerful formula for the Euler. Okay, you need to follow the Euler formula. I'll just write this again. Euler formula saying IP is a cos P, okay, I sin P. It's one of the very powerful Euler formula. Okay, then you may say for this plus minus is there, therefore they will take an average, therefore the I will disappear automatically. I am not going to detail out this in detail. Anyway, here we have a plus minus. Once we have a plus minus, okay, when we bring this E plus minus IP, that become the I will disappear here. Okay, therefore the equation will change slightly to represent the whole these things. It become the I will disappear. Okay, that's what I wanted to emphasize here. The I will disappear in this particular case lah. Okay, if I put it here plus minus again after the solution, but actually no, I don't want to mix up the Euler formula here. Okay, I don't want to mix up. This is a very important Euler formula that they will use for the complex number. Okay, which is I want you to think about this also. It's very interesting. What will happen if it's I pi? Wow, they actually something very wonderful results you may get it. If I put it is here pi, can you substitute and see? I get a solution as -1. Wow. Oh, this is something explaining the universal phenomena, which I don't want to go into detail. Now it's not time for us to discuss many what do you call the higher level mathematical concepts, but it's a very useful information for you, okay, just to ponder in lah, just to go inside and explore more. Okay, but anyway, get back to our topic here. Okay, when I combine this, I will get it here, this one, as a solution called a cos px b sine px. Okay, where the I gone here? I is a, can I say that as something okay, can you imagine this is a still imaginary number? You all know this is an imaginary number. I'll write this. Some of you still never get it what I'm writing here. This is an imaginary number. Okay, imaginary number. Can I concentrate? You know, once I put it is a plus minus here, then combine, I can just take it, this become a constant. Okay, kind of constant. In this particular case, combination of this will produce the constant. Okay, now go back further. Okay, with this with this example, okay, with this revision, I wanted to go through one more very important revision also. This is a quick revision. I take it the same paper. It's not to save the paper, but just to give you a simple quick, all the revision, put it in one paper. Okay, revision, I'm still doing revision with this, but this one is from your what do we call Fourier. Okay, Fourier series. You already learned in Fourier series one of the very important equations, whereby I take it here, okay, infinite n equals to I'm placing 0. Okay, a n cos, can I say this as okay, n pi, you can put it L x, or I can put it this as omega or whatever. Okay, as long you can understand the things. Okay, how do we solve this for a naught? Remember, I put here 0, it's not 1. That means you expand this, you will get this. Okay, can you see this? A 0. I place 0, here is a 0, therefore its whole thing becomes 0. Then this become a 1, I get a naught, plus I able to go to the a1. The a1 then is proceed. Okay, if I can proceed this way, I can continue with the my these things. For example, a1 become a cos pi l, okay, x, and etc. Okay, with that, how do I solve a naught? Can I solve the a naught? Yes, we already learned before. This can be solved with the 2l, okay, and l equal to 0. Please revise back again. Okay, the solution is fx, and I bring this whole thing again into cos n pi lx. Okay, this is one of the very important revisions. I want all of you to take note on that. Okay, oh sorry, it's not for a naught, a naught. Okay, you take it this n, sorry, try to w. Okay, for the a naught, same to L0 fx dx. That's it. Okay. Okay, I just simply changed the whole thing, otherwise I'd want to. Okay, for the a end, we can solve the solution for the Fourier series. We have this. Okay, another one more option for the fx if the case is infinite 1, okay, you can say, can I put a 0? Can, because you see, for the bn0, sine n pi lx is a 0. You put 0 here, whole thing become a 0. Therefore, no point you are using here for the sine 0. N equals to 0 is a meaningless. Therefore, now you see bn, okay, to solve the bn, if I wanted to solve the Fourier series for the bn coefficient, okay, it's a 2 to the l to the 0, fx, I bring the fx here, okay, sine continuously n pi l to the x. Okay, this is a very important. Okay, both I put this star, this one is a star. Okay, you should able to explain this very well. You should able to handle this Fourier series as well. Okay, we're going to combine these two later in all our solution. Okay, that's why I did the revision with you very quickly. Okay, again you look at this one carefully. You have 3 solution here. You have 3 solution. We're going to use these 3 solution for our cases, but let us do some example. Okay, let me try with a few examples. Okay, shall we? Okay, I have a little more minute. My battery going to finish. Then after that I'll continue. Maybe we'll go for one small break. I'll let you know when we can go for the break. Okay, by then we will do one exercise here. Okay, the first exercise here. The first exercise here is this: u t t u x. Okay, and can I solve this? Can I solve? Please solve. How do we solve this? Okay, first question. Can I directly go for this? Maybe you say, oh sir, you already taught us separation method, therefore I can use the separation method to solve. First question, you need to, before you start the separation method or you apply separation method, you must ask 2 questions. Okay, you must comply 2 questions. Again, remember, you must comply to apply, in order to use separation variable, apply to linear homogeneous method. Okay, it's a linear homogeneous method. You must ask whether this equation is a linear homogeneous or not. If it is not a linear homogeneous, you cannot use separation method. That's a very important. Okay, but very obvious, this is linear homogeneous. This is linear homogeneous. Okay, don't panic, don't get panic. Sir, I cannot identify. How do you recognize this as a linear homogeneous? Again, please don't be worried. Okay, so much. You look at this one first. Okay, can you see this? Maybe I can combine. This is x-axis. You see this one, this equation is referring to one of this. Can you see this? T x. Okay, x is here. Yes. Okay, y, maybe I can treat this as a t. Okay, yes. That's it. T is one of the, I already told you, this a, b, c, all functions, right? It's a coefficient functions. Coefficient functions. This is a coefficient, but it's a function. Therefore, yes. Okay, simple things to verify. What are they? Are they any product linear? Is there a linear? Yes, this is a linear. How do I know? No, simple things. Degree must be 1. Again, check degree 1. Okay, no product term of dependent variable. Okay, are there any product term here? No. For the tt, xx, no. Then still okay. Any transcendental function? No. Therefore, it's a linear. Is this a homogeneous? Yes. How do I know homogeneous? Okay, no g, no g, okay, no gxy, okay, no gxy. Can you see what I mean by gxy? gxy never involve the dependent function. Can you see that? Is there dependent function? You see, this gxy never involve dependent function. Can you see that? U, but g never involve the dependent function here. Okay, therefore it can be a combination of anything, but you cannot see u here. Okay, therefore are you seeing anything something like that? No. Okay, therefore it's a separable. Very straightforward. Let us try. Okay, let us try. This is, I call it as a function number 1. Okay, if a separable, let me try and see. It's a separable. Okay, I use x, t, I call it, this is a second function. Okay, u, t, maybe the first time I'll show you how to do it. ut, I'm using a u, t, differentiate, partially differentiate on the dependent function u. Therefore, this will become x, t. Okay, this I call it number 3. Okay, ux, can I do ux? Differentiate, partially differentiate on the u here. I will get x, okay, t, 4. Okay, now can I combine 3 and 4 in one? Number 1, I just bring it that up. Yes. Okay, when I start combine together, I just bring it here, t, okay, t, x, sorry, okay. Maybe some of you may ask this, sir, what about the t? Why t is, I need to bring it down to the t? You know, this is, we need to group it into a same function. Same thing, same function into one. And please don't place it on the top. Okay, any variables, okay, independent variables should not go up here. Okay, we try to avoid. Okay, with this we know we already categorize. Okay, we already group this to one single formula, whereby to explain this again, you see, can I see if fx, one function with a different independent variable, okay, can be equated with the constant. Therefore, I can say this with the lambda. Now you got it. Yes. Now you can see why lambda. See the role of lambda. That's why I say it's $1 million question. Okay. If you can see why am I putting lambda there. Okay. Lambda is very clear. This only can explain that. Okay. With this, can I? Okay. My battery going to go on. Just, okay. We try how much we can try. Then see lambda t. Okay, maybe it can last for a few minutes. Okay, number 5, I say x lambda x equals to 0, 6. The solution, if I can finish this before e lambda t2, okay, x b e lambda x. Therefore, the uxt, yes, I've done. C e lambda x e lambda t2 to the 2. Can I? It just, I solve this problem with this, I get here. Okay? Therefore, the combination of this we have done. Okay. Now, we can go for one small break. Then after that, we will continue again. Okay? The examples. Thank you very much. Okay, take a maybe 1 minute break, maybe plus minus 2-3 minutes, 3 minutes break. Okay, take a maybe a nap. Now you can go for the nap, or you can take a cup of tea. Okay,